Okay, we are going to do division of integers now. We already did multiplication, and in the last chapter we did adding and subtracting. When we did multiplication, we found out that if the signs were the same, the answer comes out positive, and if the signs were different, the answers would come out negative. Now, multiplication and division are related. I can rewrite a problem that's division as multiplication, just like I can rewrite a subtraction problem as an adding the opposite problem. So, because I can do that, when the quotient is negative, the answer to a division is negative, the divisor, which is on the bottom, and the dividend on the top, must have had the different signs. Difference, negative, must have different signs. And when my answer comes out positive, then the numerator and denominator, or dividend and divisor, will have the same sign. There's a whole bunch of examples up here. Check them out. Let's check out this question. We're going to dive right in. Exercise 2. Is the quotient of two integers always an integer? Well, this is why we do vocab, because you can't answer this if you don't know what an integer is. So let's pause for a second and rewrite it. Positive or negative whole number. If I'm going to write the set of numbers, again, another important word we went over, it looks like this. Positive and negative whole numbers. No decimals, no parts, no fractions, no repeating decimals. So, is the quotient of two integers always an integer? And just like in science class, if I want to find the answer, I'm going to experiment. We're going to use this space below to create quotients of integers, and then answer the question and use examples or a counterexample. If you don't know that word, we're going to learn it now. It is an example against something. Again, these things will show up in the vocab quiz, so you really should highlight it. If you're using Cami, there's a really great highlight button. And these things will be in the answer key at 2 p.m., so you will have a copy of the notes with all the nice details in it, hopefully. 2 p.m., check those answer keys. Okay, give me a number. 4. Give me another number. 2. 4 divided by 2 is 2. Is that an integer? Yeah, it is. Who said I had to do it in that order, though? Let's do it the other way. 2 divided by 4. If you press divide in the calculator, you will get a decimal. If you pressed fraction button in the calculator, you would get a fraction. They mean the same thing. That is half and that is half. That's a decimal, that's a fraction. They're both rational numbers, but neither one of them are an integer. This is not an integer. It is rational. It can be written as a fraction, but it is not an integer, like 2 was an integer. Okay? Even if I did like 5 over 4, I would get a mixed number. It has a part. It's not a whole. It's not negative or positive whole. It's not an integer. These are my counter examples. This is not a counter example, but these are. So will I always? No, I will not always. I will sometimes get an integer. Okay? Let's jump into some problems. When the signs are different, you get a negative. And then you can ignore it. 14 divided by 7 is 2. When the signs are different, you get a negative. 14 divided by 7 is 2. This is the same answer. And this is PEmdAS, so I do 14 divided by 7, I get 2. And then I go back and copy the negative. This is basically what I wrote on the other pages. It says I can write it in the numerator, I can write it on the denominator, or I can write it out in front. They all equal the same answer. So I'm wondering, since we're going to be doing longer problems, we're going to have to do PEmdAS. PEmdAS says if there's more than one multiplication, I just go left to right. So we'll do two numbers at once. So there's two numbers here. Both of them are negative. The signs are the same, so the answer is positive. Do I have to write the positive? No, but I'm emphasizing it right now. And then I would copy the other ones. These signs are different, so that's going to come out a -1, which I'm kind of running out of room for. So then these signs are different, so that's going to be negative. So this comes out negative. How many negatives were in this problem? There was 3 negatives in this problem, and the answer came out negative. I don't even care what the number is for this. Can you tell me if this is going to be positive or negative without using a calculator? Let me show you the trick. 2 negatives, that's the same signs. That's going to come out positive, right? 2 negatives is the same sign. It's going to come out positive, right? We multiply positives, what do you get? Positive. There's 1 negative left. This is going to come out negative. There was 1, 2, 3, 4, 5. There was 5 negatives, and it came out negative. There was 3 negatives, and it came out negative. Do you see a pattern? When I have 2 negatives, it comes out positive. When I have 4 negatives, it comes out positive. Do you get the shortcut? If you have even number of negatives, it comes out positive. If you have an odd number of negatives, it comes out negative. Okay? For the rest of this page, you are totally allowed to use the calculator, and you should do this entire thing in the calculator and get an answer. And then I want you to go back and write the other steps in and practice your PEmdAS. Yes, I hear you groaning. I want you to do it. You need to practice some old school stuff. So you can go ahead, put in 1 minus 1 times 2 times -3 in your calculator, get an answer. And that's how you're going to know if you can remember how to do PEmdAS correctly. PEmdAS says parentheses first. There are no parentheses. There are no exponents. There is some multiplication. Oh, but you know what I like to do? I like to change subtraction, adding the opposite. Makes our life a little easier. So I would multiply these first, copy everything else, then I multiply these, and then I add. Okay? You're going to practice this. That slash means divide. Check out my move with multiplication and division dance video. That slash is old school divide. The fraction bar is divide. Okay? And then when you have to do a problem that says evaluate, which remember is a super important word to know, it means give me the numerical answer. You have to do substitution. Substitution is when you plug one number in for something else. So, for example, number 8 says t minus r over 3. So what I want you to do for every question that has these letters, you need to remove. When you remove the letter, leave it blank with a parenthesis. And then I'll go back and look. It says t is negative. I wrote the entire question down again. This was where the t was. This is where the r was. There was a minus in the middle, a fraction bar, and a 3. So the t was -6, and the r was 12. Okay, if you want to put it in the calculator from there, that's fine. That's okay. But if you don't show the substitution, I wouldn't give you full credit. Okay, so you got to show the substitution. And BT dubs, the squared button is over on the left side of the calculator. Sometimes I use a squared button, and sometimes I use the caret button for exponents. Okay, so you need to finish this. and then turn it in. Remember, I'm looking for PEmdAS on these, and I'm looking for substitution with parentheses on the bottom before you give me answers. Okay, see you when I see you.